In this video we're going to continue with trigonometry and we're going to use trigonometric ratios and double angle formula at the same time. So we already know the trigonometric ratios. We know that the sine of an angle is equal to the opposite over the hypotenuse, and that's in a right angled triangle. We know that the cosine of an angle is the adjacent over the hypotenuse in a right angled triangle, and the tangent of an angle is the opposite over the adjacent. We also know our double angle formulae. So we've got sine of 2a is equal to 2 sine a cos a, and cos of 2a, we have three options here. We've got cos squared a minus sine squared a, we've got 2 cos squared a minus 1, and we have 1 minus 2 sine squared a. So let's look at an example of how we might use these together. So if tan of p is equal to 4/3 for acute angle p, find the exact values of sine 2p and cos 2p. So we've previously used this to find, if we're given one of the trigonometric ratios, we're able to find the other two. But this time we're asked to find sine of 2p and cos of 2p. Okay, so we need to use our double angle formula. So we start off knowing that tan of the acute angle p is equal to 4/3. We also know that the tangent of an angle is the opposite over the adjacent. So if we sketch our right angle triangle, and you can see here that we've got our hypotenuse across from the right angle, our opposite across from the angle, which we know in this case to be 4, and the adjacent is next to the angle, and in this case we know that to be 3. We can find our hypotenuse using Pythagoras' theorem. So we take the square root of 4 squared plus 3 squared, and that's equal to 5. We've got a Pythagorean triple there, because we've got the three whole numbers which make the lengths of that right angle triangle. Now, following this, we can see that we're being asked to find the exact values of sine 2p and cos 2p. We can see the sine of 2p is equal to 2 sine p cos p, so we need to find values for sine p and cos p. So sine p is the opposite over the hypotenuse, and we can see from this triangle that that is equal to 4/5. The cosine of p is equal to the adjacent over the hypotenuse, and we can see from the triangle that's equal to 3/5. So that part's nothing new to us, we did that 2 lessons ago, and we can now substitute into our double angle formula. So 2 times 4/5 times 3/5. And when we carry out that multiplication, we get 24/5, which is our final answer and our exact value for sine of 2p. Now we've got cos of 2p. We can use either of the three expansions for cos of 2p, but I'm just going to use cos squared of p minus sine squared of p. But if you use either of the other two, you'll get the same answer. Remember, that is the same as writing cos of p all squared minus sine of p all squared. So that's 3/5 all squared minus 4/5 all squared. And that's 9/25 minus 16/25, which hopefully you can see gives us negative 7/25. And that's our exact value and our final answer for cos of 2p. So just now would be a good time to pause the video and take down this example in your notes before coming back for example 2. Okay, welcome back folks. So example 2, given that cos of 2x is equal to 5/13, find the exact values of sine x and cos x. So this example is slightly different from example 1, because in the first instance we were given cos of a single angle and we were asked to find the double angle, the trigonometric ratio of the double angle. So it's the opposite way around. This time we've been given that double angle. Cos of 2x is 5/13, and we're asked to find sine x and cos x. So I know that I've got three expansions for cos of 2x, and the expansions which would be most useful here would be either 2 cos squared x minus 1 or 1 minus 2 sine squared x. Now, if I use the cos squared x minus sine squared x, or cos squared a minus sine squared a, that's not actually going to help me because I've still got two trigonometric ratios in the one equation, so that won't be useful to me. But if I choose either the second or third expansion, it allows me just to have the one trigonometric ratio, and I can solve for that then. So I know that 2 cos squared x minus 1 is equal to 5/13. I'm going to add 1 to both sides, and that gives me 18/13, which is equal to 2 cos squared x. If I now divide by 2, that gives me 18/26 in the first instance, which simplifies to 9/13. And you might have been happy just jumping straight there. We now need to square root both sides of the equation, so we get that cos x is equal to 3 over root 13. So that's our exact value of cos x. Now, to find sin x, we can use our triangle because we know what cos x is now. So we know that our adjacent is 3 because the cos of x is, the cosine of x is a over h, adjacent over hypotenuse. So we can see our adjacent is 3 and our hypotenuse is root 13. We can find the opposite by saying the square root of root 13 all squared minus 3 squared, and that's 13 minus 9, which is 4. The square root of 4 is 2. So we can see that the opposite is 2 and the hypotenuse is root 13, which means that sin p is equal to 2 over root 13. Alternatively, we could have come back to here. We know that cos of 2x is equal to 5/13. We also know that cos of 2x is equal to 1 minus sine squared x. So we could have repeated this process to find sine, but this is probably faster. Once you've got one of the ratios, either sine or cos, you can then find the other one using your right angle triangles. So just now would be a good time to pause the video before the screen goes blank and copy this example down in your notes before completing the assigned exercise for today.